All right, so let's continue in chapter 19 on amines. Okay, we're going to get into some more reactions of amines. Okay, remember their main property is that they were basic. Okay, and what we're going to look at first, what we can call alkylation of amines. Okay? Alkylation of amines. Okay? So remember that if we were to look at an amine like methylamine, okay? Remember the key thing you don't want to ever forget is that nitrogen has a lone pair. And so we've been seeing that it can act as a base when it attacked an H+, a proton, for example. But today we're going to see it acting as a nucleophile. Okay? So remember the difference. When it acts as a nucleophile, it doesn't attack a hydrogen. It attacks what? A carbon atom. All right? So let's look at an example. Let's react it with chloromethane. So chloromethane is going to act as a substrate. And again, the amine is going to act as a nucleophile. So here we can do a simple SN2 reaction. Okay. So the nitrogen would attack the carbon and kick off the chlorine leaving group. Okay. So if it does that, we get this here. Okay. Notice the nitrogen has 4 bonds. Anytime nitrogen has 4 bonds, it will always have a positive charge. Just like oxygen, if it has 3 bonds, has a positive charge. Okay? So, since nitrogen has a positive charge, what's that going to make these hydrogens? It's going to make them acidic. Okay? Just like if you had a hydrogen on a positive oxygen. Okay? So both of those hydrogens will be acidic. All right. Okay. So it was the same setup when we had this here. Remember that? Any of those hydrogens were acidic because the oxygen is positive. Now the nitrogen is positive, so those are acidic. Okay? So the Cl minus, what's it going to do? Take an acidic hydrogen. Okay? So note those electrons in the bond will come to the nitrogen here to form a lone pair. So let's draw the result of that. we get that there. Okay, any questions on that? Pretty straightforward. Okay, so we've alkylated this amine. This amine here was what? A primary amine, and now it is a secondary amine. Okay? Simple reaction. Well, guess what? Because it still has this lone pair, what do you think we can do? We can react it with another substrate. So let's do that. Okay? Okay, so we will alkylate again. Okay, so it'll be the exact same mechanism. The nitrogen attacks carbon, kicks off the chlorine. Okay. Okay, so now the next methyl group is added on. And what do you think is going to happen here? It's going to attack the acidic hydrogen. Okay. Is she okay? Okay, so take the acidic hydrogen and we get that amine there. So now we have a tertiary amine. Okay. So this nitrogen just loves to be alkylated. Okay. Well, guess what we have now? Lone pair. So what can we do now? Do it again. See? Nitrogen loves to be alkylated. Okay? So we can react with the substrate once again. Okay? So the nitrogen attacks, kicks off the chlorine. Okay, and we end up with our ammonium salt. Okay, so now we have added 3 alkyl or 3 methyl groups. Okay, do you think we can add another one? No, why not? We don't have any more lone pair. Okay? So we say the thing is exhausted. See that? What does it mean if you are exhausted?
Can't do anything.
Don't feel like you can't do anything else. It's over. Okay? Maybe some of you are exhausted now. Okay? So this thing cannot do any more alkylation. It's done. And so what we will call this then is exhaustive alkylation. Okay? Where that reaction has happened as much as it can do. Okay? It can't alkylate anymore. The nitrogen is tired. The nitrogen is done. Okay. Any questions on alkylation of amines? It's just doing the same thing over and over. Okay? But note, how many times did it do it? It did it 3 times.
Is that always gonna be 3 times?
Well, it'll be 3 times, unless I specify otherwise. Okay? We'll do an example a little bit later, and I'll show you what I mean. Okay, this is the first example of nitrogen acting as a nucleophile. Okay? Let's go on and look at another example. Okay, so the next way we're going to see nitrogen acting as a nucleophile is take an amine and react it with an acyl chloride. Okay. So what's the setup here? So remember, the amine carrying any number of alkyl groups. Remember our acyl chloride, we used this back in benzene chemistry, where you had the chlorine attached to a carbonyl, and then some kind of carbon group over here. Okay? In this reaction, where do you think the nitrogen is going to attack? The carbon, good. And what's going to happen here? Kick off the chlorine. See, you already knew how to do this reaction. Okay, so that will be the basic mechanism that we use. Okay, let's look at an example. Okay, so let's this time use a different amine, cyclopentylamine. And let's use this acyl chloride. Again, I could put any R group that I choose. I just chose to make these. Okay. So let's do our mechanism that we showed here. Okay. So the tax kicks off the leaving group. combination of those. Okay, then what do you think is going to be the last step? Chlorine taking the acidic hydrogen. You might remember that this functional group, where you have the carbonyl on the nitrogen, it's called an amide. We'll be dealing with amides later on in chapter 21. Okay, so any question with that reaction? Okay. One thing we can do here, if you're looking at your outline sheet, you can take the amide that is formed and react with H3O plus. Okay. What this basically does is a kind of reverse reaction. Okay. Or what it's going to do is split this amide linkage and get back your amine. Okay? And so we sometimes call this a de-acylation. Okay? Why do we call that a de-acylation? Because we have removed the acyl group from the amine. Okay? So we can get back our amine here. Okay? I say, why would you do that? Get back the amine when I already had the amine. Doesn't seem to make sense. Well, one of the reasons we do that is if you acylate the amine, this lone pair is not reactive as a base or as a nucleophile. You see? So it's like a dead lone pair. And so when I make the amide, it kind of blocks this nitrogen from doing any more chemistry. You know, if I wanted to do an alkylation, I can't do that. If I wanted to protonate it, I couldn't do that. It's a dead nitrogen. So if I had other things on the molecule here that I wanted to do chemistry with, I could, but I don't have to worry about this nitrogen reacting. So if I did chemistry on other parts, I could, and then to get the amine back, I could deacylate it and get the NH2 back. And then after that point, if I wanted to alkylate or do whatever, I could. Okay? So that's the purpose of putting this amide linkage on. And then at my disposal, I can deacylate with H3O plus. Okay? We'll do again some examples of this in a little bit. Let's look at the third reaction. Of an amine acting as a nucleophile. This time we'll take the amine and react it with sulfonyl chloride. Sulfonyl chloride. Okay? So let's look at the setup here. Okay. So that on the right is a setup of a sulfonyl chloride. Okay. So this sulfur with 2 double bond O's is the sulfonyl group. Then when I put the chlorine on, it becomes the sulfonyl chloride. Okay. What would you predict to happen in this reaction? What to attack what? Very good, attack the sulfur. See how you predicted that very nicely because you knew the fundamentals. You've never seen that before, okay? If I would have thrown that up at the beginning of the course, probably had no idea. But see how you just predicted what could happen. That's what you want to be able to do, is use your skills like you just demonstrated, okay? Not only in this course, but when you move on and go on and take an MCAT exam or whatever, you figured that out, even though you didn't really see that reaction before, okay? So very good. So nitrogen attacks sulfur, kicks off the chloride. Okay. Let's look at an example. Okay, so let's look at this amine reacting with this sulfonyl chloride. Okay. So mechanism-wise, the nitrogen attacks sulfur, kicks off the chlorine. Okay. So a simple SN2 reaction. Okay, so the amine has added on to the sulfur. And now I'm sure you can predict what happens in the last step. Okay. Chlorine attacks an acidic hydrogen. And remember, that bond now becomes a lone pair on the nitrogen. noticed in each of our reactions, the HCl is always a byproduct, isn't it? Okay. If you look here, you have the nitrogen on this sulfonyl group, okay? And this kind of functional group, where you have these two connected here, this is what's called a sulfonamide. Okay, so you see the blending of the names, kind of an amide group, but it's on a sulfonyl group, so we blended for a sulfonamide. Okay? These sulfonamide functional groups are used heavily in the drug industry, the pharmacy industry. Okay? As a lot of drugs are sulfonamides. Okay? The sulfur atom is a big group that, or a big atom that's used in a lot of drugs. Okay? In fact, back in World War II, sulfonamides were used where they would give them to the soldier in powdered form. So when the soldier got a wound on him, he would take the sulfonamide and just sprinkle it on there. Okay? And it would cleanse all that infection and everything else that tried to set in. Okay? So these things are really good antibiotics that are used out there. Okay? The sulfur atom is a particularly important atom because it can also bind to metal atoms. Okay? So in our bodies, each day when you go out and breathe air, breathe in some pollution, what makes the pollution in there a lot is the metal, a lot of metal atoms in there. So when you breathe the car exhaust fume from the person in front of you, it's not just carbon monoxide and gases like that, but it's also metals that are coming out, okay? Heavy-duty metals that are toxic for your body, such as lead, such as polonium, and some other metals that are coming out. And those metals come out, you breathe them, they stay lodged in your body, and they're thought to be the precursors for whether it's cancer or Alzheimer's disease or other things, okay? So one of the big things that you may be seeing out there as you're reading the web and other news sources is what's called heavy metal chelations that you can do, okay? Where you can go to a doctor and they inject you with an IV that has these different chelators that bind to the metal atom and take it out of your body, okay? So a lot of people are into that. They also sell those orally, so you can take capsules or whatever, and that can get in your body and expel it out through your kidneys, okay? So anyway, be on the lookout for heavy metal chelation. That's one of the big things that's going on to help people's health out there, okay? All right, so these are the three reactions for amines as nucleophiles. So now let me give you some examples to work on.
I have a question on that. We can't do like we did before with the acylation and like do it and make it go back to just have our.
Oh, with H3O plus? Yeah, this one doesn't react as much with H3O plus, so that's pretty much a stuck linkage. But good question. Okay, so work on these on your own here. Okay, so here's the first one. Note I have a 3 in front to designate exhaustive alkylation. Okay, so that's your first reaction to work on. Here's your second one. Okay. Again, you might want to write the mechanism for each of these. Yeah. Yeah. Sorry about that. Can't have two amines reacting with each other. And let's see here. Okay, so work on those. Okay. And I will pick some people to come up to the board so you can show off your knowledge. Okay, so this is showing reacting 3 times for exhaustive alkylation.
Put it the 3 of the.
Well, yeah, this attacks once. Okay, I see what you're saying. Yeah, thank you. Thank you.
second.
Yeah. I'll start writing answers here. Our time is getting away. Good. I'll leave the mechanism for you on that, as it's a, you know, 3-step long one there. Okay, but you should have got that as your final product. Second one, should have got that sulfonamide there. Okay. Again, if you want me to check your mechanism, just stop by the office.
Do we have to put the AC in the deal, or does it matter?
Yeah, it's not necessary. It's just a side product. Then the last one gives you the amine. For that.
Okay, and how do you know, and then how do you know you want to break it down?
Well, yeah, if I were to give this to you and then say, okay, take that plus H3O plus, then you would break it back
Because I
down.
ain't doing it on my own.
Yeah, yeah, so don't do it unless I ask for it there.
Okay.
Yeah. Any other questions? Okay. All right, so on Friday, we're going to use this knowledge and use it for our next step, okay? And then we'll see to finish up this chapter. Okay, so feel free to pick up any quizzes up here that you may not have picked up.